Erosion. Sam Cocke is going to kick it off. Sam's a sales manager for Double Oak, and they're a construction contractor providing services in maintenance, turf establishment, BMP installations, stormwater quality permitting, inspections, TCEQ compliance, repairs, and erosion prevention systems, which means they are very busy. Double Oak Erosion also is a licensed certified service provider and an educator and trainer for the Shore Socks Dredge Sock system, which is a bioengineered living shoreline restoration and erosion prevention system by Socks Erosion Solutions. And Sam, I'm going to kick it over to you. Take it away, gentlemen.
All right, guys, appreciate it. Thank you for the introduction. Like Ron mentioned, my name is Sam Cocke, Double Oak Erosion, and he gave you a little bit of background of who we are, but we are a erosion control contractor based out of the Houston area. We do have operations in the Hill Country, San Antonio and Austin, and then Louisiana as well. So among in addition to the things that Ron mentioned, as far as what we do, we are also, as he mentioned, a CSP for this system that we're going to talk about. And Casey is going to get into the details and the meat of this presentation, but I want to give you a little bit of background of Double Oak and how we came into installing this system. I will say we've been given this presentation. Double Oak has been given this presentation for about 2 years now, and I just want to say it's been very well received. It's basically been given to the civil engineering community in the Houston and greater Houston area. It's been very well received. I say that just to say I do think you'll get a lot out of this. You will at least find it very, very interesting, as we did when we first were introduced to this product. So what this system is from a 30,000 foot view is a shoreline restoration and hillside restoration and erosion prevention system in one. So Casey, if you have the controls, go to the third slide, sorry. So when I say it's a shoreline restoration, erosion prevention system in one, traditional ways to repair a shoreline like this would be to first pump the water level down, bring in your heavy equipment, bring in your fill, compact it, and completely restore that shoreline before we put in any kind of erosion prevention system, whether that be Fleximat or Armor Max or Riprap for that matter. To do that right means restoring the shoreline to its original design or its original condition. With this system, we do not require heavy equipment to install it. So the cost effectiveness will definitely explain how that works. But basically you anchor this system, this HDPE mesh, to the shoreline, you fill it, and as you do, the system bellies out, you reclaim lost shoreline. At the same time, you permanently protect it without having to cause a lot of disruption. So it actually came to us 3 summers ago when an engineer who was the district engineer for a mud district, and he came to us and said, my mud district wants to use this system called Shore Socks to repair shoreline that look very similar to this picture you see now. And so he asked us, what do you know about it? Do you have any information on it? Do you have any equal? I said, you know what, we've heard of it. We don't know a whole lot about it yet. We'll look into it and we'll get back to you. And we did. We spent the better part of a week having conversations with Casey and the guys over at Socks Erosion and calling other CSPs to ask about this system. We thought it was just another turf reinforcement matter, something like that. We found out that it's not. And so we actually, when we came back, we did our diligence on it. We came back to the engineer, and to answer his question, do you have an equal? We had to say, no, we don't. In fact, if this system does what it claims to do, this is a very, very unique product. You could say we think it's a game-changing product, okay? And so we immediately were interested. We planned a trip to go to Florida. We met with Casey and the guys. We spent a couple of days looking at installations, seeing how it worked. We decided right then to go ahead and become a CSP for this product. Yeah, thank you. So we arrived in Florida. We asked them where they were. They're on this beautiful golf course you see here. When we arrived, we saw something like you saw on the left, and a couple of days later, they had completely transformed it and turned it in what you see on the right, and probably in a matter of 48 hours. And the only evidence of anyone had ever been out there was the new sod that has been placed on the shoreline. So very, very minimal impact to install a permanent restoration like this. We thought it was very, very interesting, very unique. So we became a CSP, and Casey will talk to you about their CSP network. But it is something that SOX Erosion requires that a contractor be certified to install this system before they will sell you the product. They won't sell it to distributors. They don't sell it to anybody that's not a CSP. So Double Oak is a CSP, has been a CSP for the past 2 years. We also now are developing other CSPs and training them and educating them on the system as well. So I do think you'll find this interesting. It is at least something new. When I say it's new, it's not a new product. It is this product has been around for over 20 years. Installation's over 20 years old. So it is not new, but it is relatively new to this area. So I do think it'll be worth your while to learn about this system. And again, we appreciate y'all's time. So before I ramble on any longer, I will turn it over to Casey. Casey is the National Sales Director for SOX Erosion. It's a privilege to have him do this presentation. I've done it for 2 years. He's done it for a lot longer than I have. So he is the expert on this system. And so it's glad to have him here with us. But that being said, Casey, you want to jump into it? I'll turn it over to you.
Yeah, appreciate it. Thanks, Sam. And before I dive in, I'll just echo some of Sam's sentiments. Double Oak and Erosion and Double Oak Construction and Sam in particular have done an incredible job the past 2 years educating the Texas marketplace and working with engineers to help engineers understand why our system's so unique and how and when and where they should put us in spec, as well as not only install the systems themselves, but train other contractors and teach them how to install our systems, just because. So that's a testament of Double Oak and our partnership with them. My name is Casey Cittadino. I'm the National Sales Director for the company. And today's presentation is Bioengineered Living Shorelines. And I'm going to run through the company, the technology, our systems, and then at some point, I'll jump into a lot of real world projects. And hopefully you guys will have questions. And I know that most of you are muted, so please don't hesitate to throw those questions in the chat box. And hopefully someone can let me know when they come in, and I'll answer them in real time. So we are the developers of these systems. We're the manufacturers as well as the distributors. So we own the entire vertical from manufacturing to product in your hands, and it gives us a lot of quality control that we like to have at our fingertips. And everything that we do is truly designed around bioengineering, living shorelines or halting shoreline or hillside erosion. And what we've done is we've taken a patented high density polyethylene technical mesh that is sewn together in a knitted pattern, which allows the entire system to have a ripstop technology. And we've created these systems for reclaiming lost shoreline and repairing lake banks and stream banks. And two of the systems that I'm going to talk about today is Shore Socks and Dredge Socks. And for this presentation, the material itself is the same, but the deployment methods are slightly different. And I'll get into that briefly. And then at the end of the presentation, I'll touch on SOX Fence, which is our engineered perimeter control systems. As Sam mentioned, we have a history dating back roughly 21 years. Our first install was on Lake Minnetonka, Minnesota. And it was originally designed as a single layer of our technical mesh with an inner layer of burlap to be filled with wood chips and or pine straw to create this kind of floating shoreline. And if you fast forward 20 years later, we've made lots of adjustments along the way, and our system is now with 2 layers of technical mesh with a reinforced roping and anchoring system that allows us to tether into at any given point. The entire system is modular, and I'll get into some of the details of the modularity, but think giant Lego set where you can just connect piece after piece. At the moment, we are headquartered in South Florida, where all of our manufacturing and finishing facilities are. This says we have a network of 42 certified service providers. The last I've counted, we're closer to the 70 mark. We've done projects in roughly 40 states at this point in time. And some of the companies that are on the bottom are large partnership type companies like Double Oak in Texas and Louisiana, and others are multi-state or national and or all the way down to your mom and pop, father and son that are installing the systems. So from a technical standpoint, there's a couple of things I want to highlight on this slide. The material comes in rolls of 100 or 200 linear feet, and it's manufactured in heights of 6 or 12 feet. Everything from that point is sewn together in field. As I mentioned, the whole system is completely modular. What you're seeing on the edges of the material is this sewn in anchoring system that allows a contractor to tether off an anchor to at any given point in the system, so we can create stability and anchor this to the ground. When we set our system, there are always 2 rows of stakes, a bottom row and a top row. And when we set our stakes in the ground, they're set every 3 feet apart. And when we set our stakes, they're typically staggered. So if you were to look down the line, you're going to have, let's call it 75 stakes in the ground per every 100 linear feet. The most common anchor that we use is a 2x2 wooden earth stake with a 45-degree bevel and a pre-drilled pilot hole 3 inches from the top. It allows us to tie off with some half-hitch knots and square knots. It also allows, when this stake is driven into the ground, it'll cantilever away from the system, adding leverage. That being said, pending the substrate, this wooden anchor may not always be appropriate for particular substrates. Obviously, you're not going to put a wooden anchor into concrete. And I'll get into some of the other anchoring that we've used in the past. When you look at our system, I want you guys to realize that there's always going to be some amount of material on the bottom, eroded embankment, of course, on the nose, and some material on the top. You're basically creating this fold, whether it's a 60-40 or 50-50 or 70-30 fold. There's always going to be a material that's on the bottom portion, the nose and the top, creating your new slope. Most of the time you'd have to come in and prep and grade this embankment, but because our system will contour to the eroded embankment, it'll take the shape of the eroded edge, and the top portion of the system will be your new clean edge. So from a cross view standpoint, this is the same thing, except I'm highlighting 3 colors here, this yellow, pink, and blue. And when we tether into the bottom portion of our anchoring mesh, we tie off to every bottom stake, set every 3 feet apart. We also tie off to every other top stake. And the reason this is important is we prevent and eliminate any type of undermining. And then once our fold is complete, we tether from the top portion of our system back to every top stake. So you're left with this kind of empty taco shell hanging off your eroded embankment. And the material can be completely submerged in water or up on land. And ultimately, this was going to be filled with material. And then this technical mesh is designed to support root vegetation. So sod will root right through our mesh. You can plant plugs into it. You can plant anything you really want into it from a vegetation standpoint, or seed underneath it. There's a lot of technical data here, and I'm going to be sharing our engineering Dropbox. So the one thing I'll just kind of point out is the material itself has a bursting strength of 150 pounds per square inch on a single layer of material. Our dredge stocks is 2 layers, so it's got a bursting strength of 283 PSI. Now, the cool part of the system is even once it's installed, if you were to take a sledgehammer and swing at the shoreline, likely nothing's going to happen. But if you were to cut it with a knife and you created a hole, that hole is contained, so the material itself is not is not ruined. And ultimately, the maintenance piece of this is relatively very easy to fix and or maintain if there are ever issues. Let's say there is an alligator that is climbed up and figured out a way to gouge a hole. You can either sew it up or sew a patch over the hole, which is awesome on the maintenance side of things. These are some other anchors that we've used in the past, aside from the wooden stakes, steel stakes, concrete eye hooks, which you'll see in this presentation, bullet anchors for going in laterally, or arrowhead anchors for going in laterally. And these gripple hooks are something that we're testing at the moment. When it comes to filling, there are a number of ways in which you can fill our system. You can dredge sand from the adjacent water body, as long as the particulate matter and the dredge spoils are above 150 micron. You can bring in a blow truck and blow in dry sand or mulch or dirt or compost or combination of. You can bring in locally sourced fill material and wash it in with a trash pump, or mechanically push it in. I know Sam and Double Oak have been using a blow-in sand truck, and their most recent project, I believe you guys were able to fill 400 feet in a day. Is that correct?
Yes, roughly 400 feet. Roughly 400 feet of a 6-foot sock. We did it with an air pump. Basically, if you can't dredge, and I'll real briefly, and you know, in the areas that we work in, we have a lot of fines, we have a lot of clay. It's not very good for dredging, unlike Florida, where they can dredge everything and they have that micron size big enough to stay in the sock. We can dredge, but just to find that real grainy material, sandy material, takes too long. So a lot of times what we'll do is we'll have an air pump truck and we'll blow it in from up to 600 feet away from a street somewhere. Allows us to get into really tight spaces, allows us to get into yards. Property owners who back up to water bodies that have a lot of landscaping, hardscaping, trees, obstacles that we do not have to disrupt. So yes, a lot of times, since clay breaks down too fine, it's like pumping chocolate milk, and looking for that material is more difficult. So I won't go on too much, but yes, we've had some success with this air blowing system, and we're able to simulate dredging by blowing the material and just kind of staging it outside the sock, and then putting a trash pump in the water and washing the material in. As you do, it completely compacts and fills the system. And so, yeah.
Cool. We've worked with a number of different municipalities around the country, and Army Corps on a number of projects. Certainly you can see Pearland, and I think that was one of Double Oak's first projects a couple of years ago, where they got their feet wet with our system. And I know they've learned a tremendous amount since that first install. So we're going to jump into some real world scenarios that I'll talk to. This is a shore sock setup, and ultimately the CSP staked our system here, brought in, I believe, my memory serves me correctly, something like 18 or 19 trucks of dirt. They vibe tamped it all, graded it to their specification. So you notice the technical mesh is left out, and the bottom portion is still staked down underground. You can see a couple stakes sticking out. And then ultimately, once this was graded, they pulled the material back over the leading edge and contained that leading edge, and then staked everything down and vegetated over afterwards. So you go from this look to this look with our shore socks, where this leading edge is completely protected from eroding away in the future. And this jumps right into our system dredge socks in a slope format, where it is a tiered approach and it's stacked. And Sam, this is your project, so you might as well talk about it.
Yeah, so this was a developer came to us. You can kind of see on the right picture there, at the top of that bank, they were building a new apartment complex, condominiums, and they had a heavy scouring from the creek that was just eating away at the embankment and starting to compromise the future building pad. So they had prices for gabion baskets and for bulkheads, sheet piling. We were able to come in at pretty much half the cost and stake this system in a tiered structure, and put two 12-foot socks on top of each other. You can see there, once we planted the sod, it takes root. So you have a permanent soft armor system that's working like a hard armor system, and it looks natural. and eventually, you know, natural vegetation grows into the system as well. So no, this is a very, very neat project we had in the Conroe area, north of Houston.
Awesome. This is just another perfect example of how, unlike most systems that are out there, we can plant right into our technical mesh. The only thing we don't recommend is planting on the leading edge. Obviously, if you're cutting holes at that point, you're going to give material the ability to leach out of the system. But planting on top is absolutely acceptable, and there are some standard requirements. We typically recommend 12 to 18 inches apart from when you're cutting holes. And certainly if you're planting a giant, root ball, you would likely have to cut, an X in the material, dig out, plant your root ball, and then you may need to sew back up around the sides if the root ball is big enough. Ultimately, you don't want to have just excess mesh out there if not necessary. So this is really cool, and I love showing this video because this is a project that we did just south of Jacksonville. On the intercoastal with saltwater, where waves are crashing up against the shoreline, and ultimately the salt intrusion killed the St. Augustine grass, but you're getting to see someone ripping out the sod, and mind you, it's sod that's dead.
See how the St. Augustine grass actually rooted heavy through the sod. It's just the salt intrusion from the intercoastal that came up and killed it all with the king tides.
And so one of the things that I think is so important here is the fact that the sod has the ability to root through the technical mesh, gives the sod the ability and the potential for surviving, major storm events, water levels rising and falling, heavy rainfall over time, because it's rooted in. What happens is if you just have your embankment graded with dirt and then sodded over, as soon as that root structure is compromised, well, then that's when dirt starts eroding pretty rapidly into your adjacent water body or downhill, right? Sod is your first line of defense. And by us having, giving sod the ability to root through the technical mesh, we're keeping that first line of defense all the way down to the water's edge. And then this is the exact same project where the sod had died, but this is the environment that we are dealing with in this scenario. Are there any questions so far? I know everyone's muted. I don't see anything in chat. I just want to make sure that I'm asking.
I'm not seeing any.
Okay, no worries. I'll keep going. So there are two things I want to highlight here. Is two things. We did a study with Dr. Nora Demers over at the Florida Gulf Coast. And essentially, she was able to conclude that we were able to reduce nitrogen runoff by 73% and phosphorus by 58%. So not only are we coming in and stabilizing the eroded embankments or reclaiming lost land, but the byproduct of installing our system, especially when you're doing an entire perimeter, let's say around a pond, is improved water quality due to storm water runoff. We're eliminating that shallowization out of your ponds by sediment migrating and shallowing out your ponds, and we're keeping that root structure down to the water's edge. We recently started working with the St. Johns River Management District, which it may not be important to you guys in Texas, but here in Florida, St. Johns River Management District is the second largest water management district in the state, and they have essentially deemed our system to be considered land maintenance. So for any project where SOx is being installed on a St. Johns River body of water, they no longer need a permit. And I thought that is really interesting. And certainly I can provide some of this data for the group once this presentation is over. So once again, real world scenario, materials lightweight and flexible and gives us the ability to get down into an area that's heavily wooded. We have the system staked along the eroded embankment. And if you notice, the take home here is we also have our lines running, and you can see them back here, way back, got to be 50 feet behind the system. And ultimately, we're able to reclaim, call it 4 feet of shoreline. And then this was finished with by just adding pine straw over the top. In this scenario, the CSP decided, and working with the homeowner, that they were going to fill the system with limestone and then dredge sand to fill in all of these voids. In a shore SOX deployment, once again, it's staked and left open. They bring in their fill material to their grade that they want, and then ultimately wrap it up and contain it so it doesn't go anywhere, and so the end's closed. And essentially what they've created is a French drain effect. So this yard will drain very rapidly. So you can fill our system with rock and other materials outside of just sand and dirt or construction fill or dredge spoils or blown in fill. This is the city of Lauderdale Lakes. Back in 2016, Abby Fiello, who is the owner of Metro Construction, brought our system to the city and worked with their engineering group. And ultimately they switched from this traditional riprap and graded embankment in multiple tiers to our SOX system. The CSP wound up saving the city roughly $3 million on the initial phase. And since that project, we do roughly 10,000 linear feet of canal bank stabilization with the city of Lauderdale Lakes every single year. The reason that we're so successful and they come back wanting to use our system is ultimately off of these embankments, there can be a 3-foot or 6-foot sheer drop off down a canal wall. And because the system's modular, we can tether or titrate the size of the system at any given point from a 6-foot system to a 12-foot system or 18 and create this stabilized embankment. And a lot of times we can come in and drop an amphibious dredge boat into this canal and dredge sediment and repurpose the sediment to rebuild and stabilize these embankments. Traditional methods, you'd have to be taking down gates and fences, and you need excavators and barges and lots of heavy equipment to do this type of work. And we can actually, stop the system at any given point and then tie back in on the project or even years later. This is another municipality, City of Palm Coast. They have the system spec'd on the embankment like so, and also have it where we're protecting this entire weir structure. And so whether it's a graded embankment or a sheer vertical where we're tying into the concrete with concrete eye hooks, the system truly is modular. So it's 1, 2, 3, 4, 5, 6, 7 unique pieces to accomplish the goals of this particular project. Another City of Palm Coast project. In this scenario, they created kind of this landing pad before they came in and did the slope piece. But ultimately, we're creating this living shoreline versus the standard riprap, which you see on many projects, which has been a staple for many engineering firms for a long time. And ultimately, we know that this will create scour, and ultimately gravity will eventually win, and these rocks will end up in their water body, and you have to dig them out and regrade and replace them. But also the runoff that happens with the dirt here is, happens much faster than by creating this engineered and living shoreline. Rum Island, I'll click through some of these pictures just because there's no explanation needed for some of them. Carwick Nature Park. This was a project along the salmon stream in Michigan City, Indiana. Interestingly enough, while the project was only 1,300 linear feet, this was roughly 55,000 feet of coverage. And the engineering firm Weaver Consulting not only wanted to stabilize the embankment at the leading edge, they wanted complete integration of the system all the way back both embankments and up multiple lifts. And there's even a third lift on the backside. So this was a really unique project where every single piece of material was sewn together to create two different slopes. Oh, and noted that this was seeded underneath and left to vegetate through. City of New Orleans, this was City Park. This engineering firm, Bator Engineering, also happens to work with Wagner and Ball a lot on projects. This was a 450 pilot project for not just for the city and City Park, but ultimately this has led to us being a part of an 11-mile mitigation project with the city. It's a FEMA project with all hands on deck, buildings, HOA, stormwater, golf courses. They must have spent a small fortune on the website just for this project, but this was the original test. And after the initial installation, we came back and planted plugs into it. And this is what the plugs look like after about 6 months. This is a golf course in North Carolina, Sapphire Golf and Country Club. I happened to be there this past weekend checking in on it after a major rain event. Interestingly enough, this golf course floods 5 to 10 times a year, and it happens to flood over this section. And this was a 3 to 4 foot sheer face drop off, but they did not want to impede on this stream bank because it fills quickly. And so we took our 12-foot sock system and created a kind of teardrop effect. And we took a bunch of this river rock and repurposed it into the bottom toe of the sock system. And I can tell you, it looks identical to this as I was walking on it this weekend, where right after a major event and this golf course looks mostly like this, and they're just looking for additional funding so they can go ahead and fix the rest of their course.
It's Ryan here from Sox Erosion Solutions. We're out here at the Sapphire Golf and Country Club, Sapphire Valley. We got a 168-foot section that we're going to be doing a shore socks deployment. We got a 5.5-foot sheer face of eroded riverbed running all the way down, about 165, 168 feet. Beautiful environment, 38 degrees, overcast. This entire riverbed that meanders down through here has been chopping away at this creek for quite some time, all the way back to the cart path in that area there. So we're going to go ahead and rebuild this entire shoreline, stabilize.
And I wish I had the most recent photos from this weekend saved, but the velocity that comes through these pipes and out into this embankment, it's a heavy flow of material, and it's chopping up the stream bank throughout the entire course. So it's really cool to see the system, thriving in an environment that, is the superintendent is so thrilled that he wants to do, as much socks as he possibly can on the course for what they can potentially afford. Once again, another golf course type application that's severely eroded. And rather than, one of the things that I want you guys to understand from an engineering perspective is not only are we able to come in and stabilize an embankment relatively quickly and efficiently, but as Sam said, with a 6-foot system, they're at the point where they're filling almost 400 feet a day. And so from a setup standpoint and fully, deployed standpoint, it's pretty safe for me to say that Sam and his team or could do 1,000 feet in a week easily. Safe bet, 500 feet to 1,000 feet a week.
Yes, absolutely. We did that. We did about 800 feet in 4 days after it was all staked. It took about 3.5 days to fill it. So, yeah.
I mean, so from an efficiency standpoint and Sam, why don't you give these guys a range of what you have seen the systems cost from a pricing and or bidding standpoint, fully installed? You just give them a range so they have an understanding of costs.
Yeah, so it's, as a erosion contractor, we've done all the traditional repairs. First of all, we've done the riprap, we've done the Fleximat, we've brought in the equipment and done it. We call it the hard way now. We've done all that. So when you're looking at a typical shoreline, a 6-foot installation, depends on, just obviously factors like, quantity and severity and location, all that kind of stuff. But compared to the traditional methods, we're very often half the cost of using traditional methods, especially when you consider getting into tight spaces where you cannot get equipment. Then the value is, goes way up. But very often we're looking at as low as $70 a linear foot for a typical restoration. But yeah, we were very, very pleased with the limited cost and just the limited disruption and footprint and all those factors that go into the final cost. Have been very, very promising, and so we're able to get in and do things very often half the cost. And even if it's new construction, say you don't have it's a shoreline that's ready. It's a new detention pond. Obviously the biggest value is that we're restoring that shoreline, not having to bring in equipment. But even if you wanted to do this kind of system on new construction, we're still less than an 8-foot wide strip of Fleximat. And Fleximat, it's a great product. We've used Fleximat, but Fleximat has a 1-year warranty. SOX has a much longer warranty than Fleximat, at least 5 years. And so when you're having warranty against Mother Nature, that's really, really uncommon to have 5 years. Now, in 20 years of this product, there hasn't been a failure on it. So you can cut 5 years minimum. So, and then the aesthetics, when you're looking at a system that is aesthetically pleasing, that looks natural, but it is a permanent restoration. There's a lot of great pictures of Fleximat on their website of grass growing through up and through that concrete grid block system that they have. But that topsoil on top of that Fleximat eventually washes out. Getting grass to grow on it is never looks as good as it does with this system, where the grass just looks very natural. It just takes root through the system. You have natural erosion control stabilization through the root systems penetrating through this SOX system, and the best natural erosion control in the world is deep root stabilization. This system allows that better than any other system that we've ever used as a contractor. So, but cost-wise, yes, we immediately saw the value of this when we started running the numbers after we visited with Casey about cost. But generally, we are at least half, sometimes more so than that. So,
no, I appreciate that. And certainly we see costs at the installation level vary nationwide, from Florida to California to Canada, based on lots of varying factors, but certainly always happy to answer any questions you guys have on that afterwards as well. The next system I'm going to touch on is our HDPE technical mesh in a fence format. What we've realized is the world of silt fencing and perimeter control has a couple of flaws, and the one major flaw that we think exists is the connection point from the silt fence to its staking system. And it's typically a staple gun, one little staple holding that material or plastic to a fence. And when there is enough water and or wind, it pulls right off the fence. So what we've done is we've engineered a perimeter control system where it's our technology. We have our same roping and anchoring devices on the top and bottom of the fence. We've also built in a sleeve every 5.5 feet, so you can slide your T-post, H-post, or stake through the sleeve. And at the top and bottom of each sleeve, we have a brass grommet hole. So you can take a zip tie or fastening device and actually fasten the fence directly to your post. And then when you drive this post subgrade, it'll actually tension this roping channel tight and it'll almost key itself in. And then we also have a 6-inch lateral toe, this containment toe. So this is a non-trench system. that is designed for a number of different things. It's really multifunctional. And I wanted to give you guys a quick showcase of this. This also has a 5-year manufacturer warranty, and it is extremely flexible in deployment and or size. So it comes in 36 inches, 2 feet and 1 feet. The 1 foot system is called the Wattle Killer. And I happen to, this is an add-on based on a project we're doing in California. It's an animal intrusion gate, and we can actually bolt these types of things on to our system because of the technology being ripstop. So we can actually just cut a hole and slide this fence through it, zip tie it, and now you have a one-way gate for animals to exit a site. So this is just a quick snapshot of our fence at the Auburn International Erosion Control Field Day a couple of years ago. You know, we can stake the system down steep slopes into water, up a gradual slope. And once again, this is the amount of sediment that's being contained before it's left to just go over your traditional erosion control methods like straw wattles. The other major take home for us is our fence itself weighs 15 pounds. It's extremely lightweight. I can put 2,700 feet on a pallet. A straw wattle, you can get 100 feet on a pallet. With our 1 foot high wattle killer that weighs only 7 pounds, I can put just sub 6,000 feet on one pallet. So from a logistical and space saving standpoint, aside from performance, is we feel really strongly that if we start educating the marketplace on our fencing system, that people are going to start looking away from some of the traditional methods. And these are just some of the ways that we're utilizing our fencing, whether it's protecting walking trails or access roads, or turbidity curtains, or ag as a for ag runoff in the ag world, wave break. We have guys that dredge and create these dewatering areas or dewatering pens and dredge sediment behind the fence. We have guys that have utilized in extreme bank situations to slow the flow of water, or protecting drain lines on construction sites. We can get really creative with the fence and all of its uses, but I wanted you guys to have a snapshot of the fencing system, and I certainly can get you more information afterwards. And then lastly, we have been wanting to do a beach renourishment project for a long time. It looks like it is finally happening in California. This is a dune socks restoration project where it is going to be a multi-tiered approach. We are working with NGO, which is a geotech engineering firm, on the design, but they have asked us to go ahead, and we're working with them on doing this project, and it's going to be likely 3 or 4 tiers, and certainly the energy that we're going to be up against is everything that you could imagine on Pacific Coast waves crashing up against a house. So this is going to be a fun project to be a part of. And the other thing that I wanted to make available for you guys here is, and I can have Sam or myself send it to the group, is this particular sheet that I've put together. It essentially highlights all of the line items to consider when thinking about a SOX system. It was certainly designed for our contractors, but per some conversations I've had with engineers, even this morning, they thought this was really helpful. And so in here, it talks about our SOX technical mesh and sizing variations, the anchoring specifications and details, the rope specification details, sewing, whether you're doing it by hand or you're going to use a field sower, the mobilization, vegetation, training rates, contingencies, and then even sample reporting. So like this is a field report that one particular customer shares with us, and they will essentially highlight the project or the pond, the total linear feet. This says 1,400 feet. Then with pictures, and once I have a report like this, I can have a really high level intelligent conversation with that particular engineer or contractor based on the project at hand. So this is also available for you guys, as well as an entire engineering toolbox if you guys need it. So, but I'll stop here because I know we have about 10-15 minutes, and hopefully you guys will have some questions that I can answer. And I appreciate you guys taking some time to learn about SOX.
Hey, Casey, this and Sam, this is Ron. I actually have a question for you. This system is something that would be, are you looking to have authorities such as government agencies, things of that sort, specifying this system, or are you bringing that in from a different angle? What is your, if you had a magic wand and you could have it the way you would want it, is that how it would be approached?
Yeah, certainly we take the approach of education first, but ultimately, yes, our goal is to have, government, local, state governments and engineers understand that our system is going to outperform the traditional methods of gabion and riprap and just grading, right? And creating a long-term, long life cycle solution that's cost efficient and effective, for various environments. And yeah, ultimately our goal is to have it be a standard and in spec for these particular projects. From a company standpoint, at the moment, our business is twofold. One is educating the engineering community to ultimately drive specs, and B is educating and training the world of contractors and or companies that are interested in providing this suite of systems into their core business. And not only do we train them on how to install the system, we provide them a lot of material that they can go out and ultimately sell the system locally, whether that be to the golf courses or HOAs or whoever their core customers are. So we're creating, a business within a business for many companies who are unaware of our systems. As I mentioned, Sam and Double Oak have been incredible partners for ours in Texas, but we have 70 CSPs nationwide. I'll also throw out there to the entire audience, I don't know how many people are on the call. I will be in Houston and Dallas next week, meeting with Sam and Double Oak, and out on projects, taking a look at a couple of things. And if any of you needed or wanted to meet with me in person, I'm happy to try and accommodate if I can fit it into my schedule.
What I'm doing is I'm typing my contact information into the chat here, but it was on the first slide. If you didn't get a chance to write it down, it's okay. Please, if you guys want to look at projects, if you want to look at some installations that we've done in the area, please give me a call. Got my cell phone number on here too, and we can go look at some projects that we've done.
Yeah, I just to echo that, Sam, I think it's a great idea. I will say this. Certainly looking at pictures in videos is cool. Seeing it installed real time is amazing. And standing on an embankment that was not once there, 10 minutes prior is really tells you a different story of how fast and how stable this is. And it's always the standing on the shoreline piece that gets people to have that aha moment. So if you are and can take advantage of getting in onto a project with Sam, I know he'd be thrilled to have you out and on any of his projects. And you guys have a lot of them coming up.
We do.
Right.
We do. We could set up a demo for you guys as well. We can go, we've done that often. Yeah, we can go watch it happen live. And that truly is the difference, seeing it happen in real time and having nothing to stand on to 10 minutes later, standing on something that feels like concrete that's growing grass on it. Please let me know. We'd be happy to stage a visit with you guys and watch it install live for sure.
Is this something that would be reasonable that you could work into maybe a technical tour for our young member groups at the various ASCE branches? in areas where you're doing these projects.
Absolutely, but say that's, what are you talking about specifically again?
So our different ASCE branches around the state have young member groups that typically set up various technical tours where they will go to manufacturing facilities, job sites to actually get more of that real world hands-on experience. And I just thought, just popped into my head when you said that might be a great opportunity for branches that are in an area where you're doing a project to be offered up for one of their technical tours.
Oh, yeah, absolutely.
I think
If
it's
you
a
want to
great
tell me
idea.
who to coordinate that with, we would love to do that, obviously. I think that's a great idea. Yeah.
Okay. Excellent.
Hey, Ron, you had a great question before. What's the, now that you've seen the system firsthand, and I hate to put you on the spot, give me your honest thoughts and feedback here, since this is the first time you're seeing it.
So, it's not my area of expertise, but, from a system, we're always looking for things that work better, as good as, that legitimately work better. There's a lot of things that come along and claim they're just as good, they're better than, and to have something, that can come out that, is an engineered system that does actually do what it says it's going to do. Whether I can say it works better than existing systems, again, that's not maybe some of the other folks on here would have better, better ability to speak to that, but it's very intriguing, and it's something that is an interesting alternative to what's currently being done.
Well,
Yeah.
let me say this real quick. As a erosion control contractor, we deal a lot of times with, you ready? Okay. We deal a lot of times with, especially turf reinforcement mats, coming out with another system that it's the same thing, it just called something else. This one is the first time we actually came across something and said, man, people need to know about this. It's a lot different than anything that we've seen before. So we don't just present this as an excuse for an audience. I truly, genuinely thought we really need to tell people about this, because we really think this is a different kind of system, different from anything that we'd seen before. So Casey, I know you probably want to add to that.
No, it's listen, we've seen the system installed on a number of applications just to help you guys understand size and capacity. And I know Sam is jumping. To date, this year alone in 2021, we have completed just about 100 installations nationwide. And so it's not like we're doing 1 or 2 projects a year. We are actively installing the system around the country in various topographies and environments. And we know what the system can do. And we're always anxious to, be a part of the next project and the next test to showcase exactly what we already know. So it's just a matter of education, and if and when there is a project that makes sense and calls for SOX, hopefully you guys will think of us and consider the system.
Good. I don't see any other questions. Sounds like we're going to have to recruit you all as an exhibitor for our civil engineering conference, Casey. We will.
You know what? You can recruit me. We're open.
You will be recruited.
We are open, and we know that the Texas market is a huge market, and like I said, Sam's done a great job in Texas, in the Houston market, but obviously we have done much less in San Antonio and Austin and Dallas, and it's a big place.
Indeed it is. Mike,